We're going to run through 2 scenarios, and that's going to be it with exponential. Then we'll run through 3 scenarios with logarithm, and we'll be done, just so you know where we're going with all this. So scenario 1. For exponential, I'm going to call this base manipulation. We're doing the same thing in 3 classes, and I'm at 3 different places. So if I say something that I've already said, stop me and tell me that we've already talked about that. And if we haven't, then tell me you're confused and I'm talking about something you don't know. Now, tell me this. If 3 to the 2nd power equals 3 to the x power, what do you know about x? It's got to be 2, right? Plain and simple. Everybody understands that, right? X has got to be 2. If 5 to the x plus 1 equals 5 to the 9th, what do you know about x?
8.
It's 8. You're doing that in your head, but what are you doing?
You're just solving the x.
You're saying x plus 1 has to be equal to 9. Why does it have to be equal to 9? It's an equation. They equal each other. The bases are the same. Therefore, the exponents must be the same. Does that make sense to you? Okay? And I know that seems, you're looking at it like, of course they do. I show you that for a reason, a very, very basic example, because yes. When the bases are the same, and when we're talking about we just have one exponential piece on either side and that's it. The bases are the same, then it follows that the exponents must also be the same. So that sounds pretty self-explanatory, and that sounds like it's just common sense, right? But what if I had, I'm going to go to the next page to do it, so tell me when you're, I know. Let's say I have 3 to the x plus 1 equals 9 to the 2x minus 3. Can I set the exponents equal?
No.
The way it is now?
No, not
Why?
because you have to multiply by 3.
The bases aren't the same. Okay, multiplying it by 3 is not going to get me there, though.
Can you multiply the x by 3? Because you're going to have to multiply the base by 3.
Okay, so no, I see what you're saying, but you can't do that here because the exponents are throwing you. What you can do is you can rewrite them to where they have the same value, written a different way, but have the same base. In other words, do you recognize that they are both powers of 3? Yes? This one is already a power of 3, right? How could you write 9 as a power of 3? 3 squared. Do we all agree that it is the same thing? This is why I call it base manipulation. You won't find that written anywhere else. That's just a made-up little expression. But you manipulate the base to make the bases the same, because once the bases are the same, it's a duh, set the exponents equal problem, right? So force the same base where you can. And so you might be tempted to look at this and go, oh, well, I'm just going to multiply this first one by 3 to make it 9. But remember, this is an equation, and it has to stay balanced, right? So I got to keep it, whatever I do to one side, I have to do also to the other. So by just writing it a different way, I haven't changed its value. So now I can take each of the exponents, and I can set them equal to one another. And does that look like something now that you might be able to solve? Yes. Not in this form, not whenever it's just 2 like that. What to do, what to do, what should I do? Subtract x. If I do that all at one time, is anybody going to be confused?
No.
Somebody say it. Okay. Okay. These are gone. This is 7. 4 minus x, or 4 minus 1 is 3, so you have 3x. So what's the answer? Oh, love the enthusiasm there. Does that make sense?
Wait, you were supposed to multiply the exponents?
How might you force the same base here? Yes. That's exactly right, Chandler. 2 to the third. I've got the x there. What's the second one? Mm-hmm. Once the bases are the same, drop them. So I have 3x equals 2 times 3. Must mean it's time to go home. Thank you for the support there. Appreciate it. So I get 3x equals 6x minus 2. And then it's an easy solve. I'll just run through that real quick. So you get 2/3 negative divided by a negative there. Same scenario is you only have one exponential term. You may have a bunch of other stuff. So you see one exponential term in there and that's it. There's other stuff in there, but there's only one base that has exponents on it. Nothing else has exponents. So maybe it looks something like this. The first thing we're going to do is we're going to isolate. What does isolate mean? Get it by itself. Isolate the exponential term. How are you going to isolate that exponential term? Add 4 to both sides. Does everybody see that? I could have something be multiplied in front of this x, in which case, that's 7, in which case I would have to divide both sides. But right now, that's the only thing keeping it from being by itself. So you might have a guess how we'll solve it from here. I'll give you a hint. I told you yesterday, whenever you get stuck and don't know what to do, you should always do this. Change the form. All right, this is where first block got stuck. They could not remember how to change the form.
So this is where you, hold on. This is called like change the base or something?
Just expand.
How do you change forms?
That's what we're trying to do. We're talking through it. What do?
You expand.
Log. The base is 7 of 18 equals, because logs always equal exponents. Y'all did way better than first block on that one, that's for sure. So remember, we've got exponential and logarithmic form, and I'll write them over here in case you forget. B to the a equals x can always be written as log base b of a. Oop, nope. I should have done b to the x, but I didn't. Log base b of x. Let me change that. Sorry. I'm sorry. You could have kept on like that, but I want it to be the same as what we started with yesterday. B b to the x equals a, and log base b of a equals x. Okay, so be able to go from one to the other, top to bottom, bottom to top, so that you can change form so you can solve, because now it is an easy solve, or it should be an easy solve. What is log base 7 of 18? Close. Got to use your calculator. It's going to be a decimal, because 7, there's not anything you can raise 7 to evenly to get 18. 7 to the first is 7. 7 squared is 49, so it's somewhere between 1 and 2. So, no, what? 1.485. In case you forgot how to do it, it's log 18 divided by log 7. Oh my goodness. Now is this an equation that you can solve? Surely. Surely. Oh, surely. Take it out at least 2 places. You don't have to take it 3, but take it out at least 2. Now solve. Add 3. And divide by 2. 2.2425. Tell me what you think about one exponential piece. If you can change forms, you can do it. One exponential piece is pretty easy. Y'all want me to do one more? Okay. One more. This one will have an E in it because we want to. What should I do? Divide by 4. Before you change forms, you have to get the exponent part by itself.
What?
E to the 3x equals 1/4. Now what can I do? Now I can change forms, right? What's it going to look like when you change forms?
It's gonna look like n.
Log base E, which is ln of what? 1/4.
So which one is it, log or n?
They're both the same thing. Equals 3x. All right, look, you got to be able to go between all the forms. Watch. This is still log base E is the same thing as ln.
What is ln?
Natural log. Log
That's
base
a button
E.
on the calculator.
It's a button on the
I
calculator.
thought you only used the ln whenever there was an e.
There is an E.
Yeah, I'm saying, yeah, that's what I'm saying.
Yeah. So I could write this as log base E of 1/4 equals 3x. Or I could write it like that. I write it like this because my calculator will do natural log this way. Okay? What is the natural log of 1/4? Someone with a calculator. Anyone. Either one. Doesn't matter. Negative 1.386. Thank you. Now divide that by 3.
Can you just leave it at 1, -1.386?
Well, since you got a decimal there, you'll want to divide by 3. You got to get x by itself. Somebody with it on the calculator, what is it? Negative what?
4.62.
Thank you. You sure?
Negative 0.4.
It's 0.4.
0.462. Shh, shh. That's the answer.
How much more have we got?
Yes, yes. All right, now we got logs and we got 3 scenarios under logs.
How much more we got again?
Three scenarios under log equations. I know, I'm sorry. I'm trying to hurry. Scenario 1. I didn't mean to, I was drawing a line under it. These steps are going to be exactly the same as the exponential steps with one exponential piece because logs are exponents. Okay? So let's say I have log base 4 of 3x equals 6. Okay? The 3x is hooked to the log, so you can't split that up. If there was anything added over here multiplied in the front, you would need to make sure that you got rid of that first. So our first step is still to isolate the log. Do not move what is hooked to the log already, okay, that is part of the log. Once it is isolated, what do you think you should do? Change forms.
Oh my God.
Look at you, Macy.
Yeah, it's like 2 lines up.
That's okay. What is the base? 4. What is the exponent?
3.
Logs equal exponents.
Oh,
What does it equal?
3x.
3x. Look, if you have to write that beside each problem, that b to the x equals a, log base b.
I'm not doing
Okay, well,
that. The actual.
have it somewhere where you can look. Have it somewhere where you can look. Because you got to be able to change forms or you won't be able to do any of these problems. All right, what is 4 to the 6th power?
4,000. Divided by 3.
Yep.
1.
Mm-hmm.
1,365.3. 3.
All right, I'm not going to spend any longer on that because that is easy peasy.
Good. What
That's
else
it?
we got?
What's
Yep.
the little dash above
That's
the
it.
three?
That's it.
That says that it repeats. The 3 repeats forever.
Oh, God.
All right.
Oh.
Scenario 2 is also a simple scenario. Scenario 3 is the only hard one. I saved the hardest for last. I know, but it's okay. It's still not even hard. Scenario 2 is 2 log terms, nothing else. And I mean nothing else, just the logs, and that's it. Okay? They must have the same base for this to work. But if you have something, and I am not going to spend long on this at all because this rarely happens, but should you get lucky enough for it to happen, y'all should hope this is on the test because it's super duper easy. If you get something that looks like this, the logs have the same base, there is nothing but 2 logs in the equation, that is it, nothing else. Yep. So then you do x plus 1 equals 2x minus 5. It's kind of like the same thing where we had, if the bases were the same, we dropped them and set the exponents equal. We dropped the logs and set that little piece equal to each other, and we solved from there. Mm-hmm. Subtract x. I'm writing 6 and my brain's getting ahead of my hand. That's it. Y'all okay?
Yeah.
Because we're blasting through this.
Get it, come on,
No,
girl.
let's do the last one. I never will, that's fine. I don't know what's going on.
Hey, and then we're done. Yay! Two or more. I don't know what's wrong.
You doing something?
It feels just like I feel today. Two or more logs. Maybe more stuff.
Maybe more.
Yeah, I think so.
Maybe you're adding something or subtracting something. You have all kinds of stuff, but at the end of the day, you have two or more logs also. Okay? So maybe a scenario that looks something like, let's do natural log. This. I've got two logs and I've got something else. I've got some other stuff. I've got a 4, right? If the 4 wasn't there, I could just put the natural logs on either side, drop them off, and 3x would equal 2. But I do have the 4, so I have to take that into account. So the first thing you want to do is get the logs together. Excuse you. You are a gassy young man.
So now you just do
So now, what do you think you do?
natural log, 3x.
How did you know that?
It's just
Good
compressed.
job. You have to, because I need it to be in the scenario where there's only one log, the only way to get it in a scenario with one log is if I condense it. So I'm going to condense just like I did yesterday, because when I condense, I end up with log written only one time. So whenever I condense this, what does it look like?
Natural log, 3x.
Now I'm back to scenario number 1, solving it with one log. So what do?
You always condense.
Always. If there's more than 2 logs, always.
So you type in the L.
So what do? Look back at your notes. If you've got one log, isolated, is it isolated?
Wait, more than 2 or just exactly 2?
1. Change the form.
So you condense when there's 2 logs?
Yes. How do you change this form? Please, somebody. Here's where you have to think about what natural log means.
Log base.
So it's the same thing as log base E. So change the form.
Equals.
E to the 4th.
That's it?
Solve it.
Oh.
Well, remember the whole goal in the beginning of this was to solve for x. E is a button on your calculator. It is an irrational number.
I got it.
So just like in the others, you found a value for log whatever and it was a crazy decimal. Find the value, the decimal equivalent for e to the 4th. 54.59. And now how do you get x by itself? What do you do first?
You
I would multiply by 2. Or you can multiply by the reciprocal. You can divide by 3 and then multiply by 2, or you can multiply by the reciprocal, or you can multiply by 2 and then divide by 3.
Wow.
Any of those scenarios, okay? If it was me, I would do this. And then I would divide by 3. I don't know what that is. Let's see. What is it?